Hello, everyone. I'll just make a coffee and I'll be right there. Hello, guys. Hey, long time no see. How's everyone? Hey, Helmut. Hey, Pinecone. Cheers. So, you can tell me if the mic volume is off, etc. Like, it's a new setup. Sander, like the audio guy from Better Software Conference, was kind enough to help me pick out a new mic after my old one broke. And I don't think I did a few video calls with it, but I haven't. Yeah, if the levels are off or something, or if you're annoyed by my or something, let me know and I can try to tune things. Okay. How have I been working with Thecla? Yeah, I've been. Everything's been pretty great. I'm there's just I'm very busy right now because I have like 3 projects going on at the same time, Thecla being one of them. And and I'm renovating an old house, and that's an ongoing thing. And I mean, it's making progress. We're getting our new windows on Monday and Tuesday and Thursday. So next week, new windows come in, and then like all the internal stuff has to get done. Like we don't have even, what do you call, what's Estrich in English? I have no idea. So we don't even have like a concrete floor yet. Whatever you call a thing that you pour in to make everything level inside, that's not even in yet. So it's going to be a couple of months more of that. So yeah, I've been mostly working on stuff that I cannot stream, so I haven't streamed. But this is something I can stream. I've done some preparations off stream. Yesterday, I just kicked off the compile cycle for LLVM 22 because it takes on Windows. It takes hours because you need to make two builds. One against the Windows C with debug info, whatever you call it. There's these two versions of I don't even know the names of these things. But basically, you can compile against the. Let me look it up so I don't. What's this thing called? The C runtime. You have the MTD and the MT variant of the C runtime, and we have to. So on Windows, we have to build twice, so it takes twice as long, and it's slower than on macOS. So it takes forever just to make the build, but I've done that. It seems like they have completed successfully. So now we can try to switch to LLVM 22 and see if things got faster. The first thing we need to do for that is actually not Sokovan. That's the next game that's unannounced. No, I'm kidding. We'll pull the latest Sokoban changes, and then we'll compare the compile times of the compiler with LLVM 21 against 22, assuming that we can get it to compile. I already did some experiments on macOS, like I compiled it first on macOS, updated we have this build LLVM script, like Jai program, that does all the heavy lifting. And of course, with LLVM 22, they reorganized everything again. So before you had separate source packages, and now you have one source package that you need to download. So things are in, of course, things had to change about the build process. You have now lots of like, if LLVM 22 do stuff, otherwise do other stuff in here. So I did that on macOS already and compiled it on macOS and made the compiler compile on macOS. But it was simple, like from 21 to 22, I literally just had to change one line because of a deprecation warning. So it compiles, but I already saw on macOS that we seem to have a huge regression in libclang, as in it seems to no longer report anything about template parameters to us, which would be really bad. It doesn't affect the compiler itself, but it would affect the bindings generator. So I assume it will be relatively easy to get the bindings generator to work. To get the compiler to work, the LLVM backend. And then we're probably going to spend hours to get the bindings generator to work with the new libclang 22. Maybe, like, if this turns out to be a pain, maybe this is the time to just abandon libclang and go for the full Clang C++ interface. But I took a short, maybe a year ago, I just did some exploratory programming to see what that would involve. And it's not fun. Like the libclang gives you a C interface. Like, in case you guys don't know, I know I'm ignoring chat for now. I'm gonna go back to your questions in a second, but I just want to finish that thought. So libclang gives you a C interface to call clang and then get information about the syntax tree. And this is it's a handful of functions. It's not that bad. Okay, it's 5,000 lines of bindings, but you get the idea. It's not that bad. It's mostly comments. And you have things like navigate, like visit all the children of this tree or visit all the root nodes, and then just get information about the syntax tree and build your own structure from that. The problem is the C interface has this one unexposed. and unexposed declaration, unexposed expression, and just unexposed statement, whatever. You have this unexposed. And this is what they return if there's something. So this is a wrapper. This libclang is a C wrapper against, like, around their C++ interface. And there's tons of constructs in the Clang syntax tree and in the Clang API that they just do not give you access to via the C API. If they hit some things that they don't have a representation in their C enums, for example, they don't have a representation for it, or they thought it would be too hard to navigate or whatever, they just return unexposed, or they didn't implement it yet or whatever. They return unexposed. And at that point, you're hosed. There's no way for you to get information about what's underneath that unexposed node. This is like, yeah, you would be interested in the information. Sorry, you can't have it. And we have that in a bunch of places. Like if you look at the bindings generator modules, the module, like you see, oh, if it's unexposed, and then you have to, there's lots of code in the bindings generator that's just about dealing with unexposed. Like you can see like huge loops and things that are just an experiments that just try to get some information, like just looking at the tokens and whatever, just to get something about, to dig into these unexposed nodes. And that's of course flaky, and that's usually what breaks with every LLVM update. And it seems with this new update, they just no longer give you certain children that we need to make information, like to make sense of some of the unexposed nodes, which would be bad. If that happens, we need to switch to C++. Use their full Clang API. But this is like, you've seen the LLVM codebase probably, with maybe with me on stream. It's as C++ as you can imagine. Like imagine your worst C++ nightmares, they're all in the LLVM codebase, all of them. And so the Clang API is full C++iness. So it would be a nightmare to interoperate with that directly from Jai, because there's all STL stuff in there and like whatever. You'll see. So I don't know yet what we're gonna do if actually libclang broken. Like, let's see if LLVM 22 is actually faster than 21, which is why I did this experiment today. Like why I'm trying to update to LLVM 22 is like maybe it's faster, because LLVM 21 is so slow, and some of the recent major releases actually made LLVM slightly faster. So I hope we can get a benefit there, because the release build times for Sokoban are not fun right now. I'll show you while we're talking. Let's make a final build, which means optimized, of Sokoban right now. Oh no. It seems like, oh, that's bad. Seems like there's an update. Someone changed something on the Jai modules that I haven't pulled yet. Let's do that. The problem is just that means I need to rebase my LLVM changes, and that's going to be slow. I mean, it's not a deal breaker. It's not terrible, but okay, let's pull in the latest changes so we can compile this one. Okay, let's look at chat in the meantime. New family home or just flipping house? Nope, new family home. We've been looking for a new home for 8 years, roughly. And we found one finally last year in March and bought it. And but it's almost 100 years old, so it needs a full renovation. And that's what we've been doing since last summer. Hey, Nanometer. Building LLVM with Visual Studio takes hours. If I try to generate Ninja with a CMake instead, it takes 20 minutes. Yeah, I think on, let me check. I think we're using the Visual Studio version. Like we're using CMake on the other operating systems, but I think for Windows, what are we doing? We're doing a CMake. But I think on Windows, this generates a Visual Studio project that then gets built. Yeah, so we use the Visual Studio 19 generator to generate a project and then built that on Windows. Yeah, and it's an MS build, as you can see. And this takes forever. So if you say that the CMake variant is way faster, if you can give me some pointers of what I need to change, like what do I have to pass to the configure CMake command to make it a Ninja build on Windows, I might try that, because it's so slow to compile. It takes many hours. Hey, cute math. LVM needs to go. Yep, I agree. It's great, as I said hundreds of times on this stream. It's great that LLVM exists, but boy, is it terrible. Your thoughts on LSPs and the lack thereof for Jai? That's fake news, my friend. There is an LSP for Jai. Buongiorno. Is Rhizoma Italian, or just Chris Leitner is a compiler wizard? Yeah, but he's a dark wizard, I think. He's the guy with the all-seeing eye and the glass ball in the tower, you know. Okay, we fetched these changes. That's harmless. Wait, why don't I see them? There they are. Okay, let's push these. And let's pull them on Windows. Yeah, now we have, this is not going to be fun because we have all these compiled things already. So they need to be stashed and reapplied and ugh. Okay, let's do stashing. I hope that muting worked. Otherwise, sorry for the cough. Okay. Can you please give me... So yeah, a disadvantage of the new mic is it doesn't have a mute button. My old one had a mute button right on the mic, which was like, it's not great from a technical perspective because every time you hit the button, you're also bumping the mic. And a new mic doesn't have it, so I bound. Yeah, it doesn't work. Awesome, doesn't work. I bound some hotkeys in OBS to muting, but it seems like they don't work if I'm on the Windows app because they get forwarded to Windows. So this should be muting. It's not muting. If I'm on macOS, doesn't work either. Oh, that's awesome. Let me check that. So let me show you. I have this set up. F13 and F14 are bound to muting and unmuting. And it seems like that works, okay? It works if OBS is on focus. If I switch to the terminal, it doesn't work anymore. Who makes hotkeys that only work if the... Okay, is there a way to make OBS hotkeys then work when OBS is not in focus? Like I had this set up, but that doesn't work, and it seems there is no option to. That's bad. We need that. Oh, never disable hotkeys. That's a lie. We just saw that it doesn't work. Okay, let me show you. Here's my streaming window. OBS is in focus. Works. You can see it here in the top right corner that it works. Not muted. Not muted. Let's focus the desktop. Muted, doesn't work, not muted, doesn't work. Muted, doesn't work, not muted, doesn't work. Awesome. Maybe this is a conflict between some other bindings. So let's give it something more exotic. Let's say command for F13, command F14. Nope. Let's pick a different setting. If anyone knows how to do this, I'm grateful. Otherwise, we have to experiment, or we'll ask an LLM. Haha. Okay, let's say Command M for mute. This works. Awesome. Yeah, that's a good point. Nanometer. Yes, an LLM. You grant input more conditions and system settings. It would be awesome if they said that somewhere. Okay, let's go back to F13 and F14 because that's easy. Yeah, I discovered, I didn't notice this until like Sander mentioned binding something to, I can't remember, but I looked at my keyboard and I was like, what key could I bind? I have up to F19. I have keys up to F19. Can you see that? I didn't know that until I never noticed that. So many Fs. Okay. Okay, let's do the system settings. And we go to OBS. Nope, we go to key. It's probably security or something. Oh God. The new, like, not a rant coming up. The new system settings, new as in like probably 3 years ago, 4 years ago, they're so bad. They're so bad compared to what they had before. Before you had a really good search that highlighted where things are, etc. No, now like whoever in turn designed and programmed this should be fired. And it's been like for many major versions now, and it's still bad. Okay, what do we want to say? Keyboard. It's probably somewhere, whatever. System settings, because the system's privacy. Of course, it's privacy. Why not privacy? What is that in Datenschutz? And then we go to this one. Probably this one. Yeah, that's fine. Okay. Oh no. I'm not gonna kill OBS now. Thank you very much. That's awesome. Okay, so we can't use it until we restart OBS, which we're not gonna do in the middle of the stream. So I assume this doesn't work right now. Yeah, okay. Too bad. Okay, next stream we're gonna have a mute button, maybe. Isn't that great? So I'll try to cough into the other direction for now. Has Xcode improved at all? If by improved you mean gotten worse, yes, a lot. It's not just slow; it's less discoverable. It's worse. You can't have. Okay, small usability rant. Okay, guys. Old macOS had this was a big window, and you had icons for every setting in rows, and they stayed in the same place. Guys, you can't imagine. Like, I'm not sure if you can imagine that in current in the current environment of software, but object persistence was something that was considered important so you can develop muscle memory. Object persistence is the thing that 3-year-olds, or no, not right, 2-year-olds learn. No, younger, 1-year-olds. It's probably no. It's like within your first year of life, I think. I can't remember. Kids learn that object persistence is a thing, as in like I have a funny little cube. I put a blanket over it. It still exists. When you're a toddler, you don't know that. Things that are behind someone's back cease to exist. And then when they come back, you're like, oh, wow, there's a new cube, or it's what happened. And then as you grow older, like, I don't know, a couple of months, you can read it up. They learn that if you take a cube and put it behind your back, it still exists. It's behind your back. You have to learn that. Software used to know that, and we've forgotten it. Like, it's like when on YouTube, you click on a video, or you're like, oh no, that's not it. You go back, you see a completely different set of videos. Like, there's no persistence anymore. You know what I mean, right? There's so many UIs now that like forgot that it's important to keep things where they are, where they were. The system settings used to have separate icons in fixed places for everything. So you could remember that keyboard was somewhere in the bottom left or whatever. Now you have scrolling lists. Scrolling lists are flexible and no one has to think about where things are supposed to go to make sense. You just put them in a list, and then if you have a new item, you just put it in the list and everything's fine. Problem is, you can't develop any muscle memory. Like you're like, yeah, it's probably somewhere towards the bottom, I think I remember. And then you click on something and you have more lists and it's like, oh shit. And like, you know what I mean? It's worse, simply worse. And someone took a good UI and made it worse. Any chance to push it for a new beta soon? Yeah, I'll mention it to John. Which bug was it that's annoying you? Yeah, and the problem is like Helmut, the old search, when you typed something, it showed you like it did the thing that's now bad because we don't want to do that. What's skeuomorphism? It took a spotlight and put it on the thing. So you had all your icons stayed in place, you searched, and it put a spotlight on the thing where the thing you were searching for is underneath. And so you learn to click there to find that. You know what I mean? So again, persistence. The objects don't move around. You see still all the objects, and the thing that you're searching for is highlighted. So you see where it is if you don't search. The problem with UI is like this. Let's do it again. If I search for keyboard, okay, I now see that these are the options. I have no idea how to find them except for typing. So I always have to type because I can't find this stuff without typing. Because if I clear the filter, they're somewhere else. So this is, oh yeah, it's so convenient I can type. Okay, now, but I have to type now. I can't find this without typing. Because if I clear this, where the fuck is this thing I just saw? You know what I mean? You can't get better. This UI doesn't allow you to get better at finding things. And this is so common now. And these are all things, what drives me crazy about this is, it's not that I have this secret knowledge that no one knows and, oh God, if people just knew they could make better UIs. No, I learned all of this from people who knew that in the 80s, 90s, okay? There are books written about this kind of stuff in the 90s. There's probably in the living room, but there's the design of everyday things by Donald Norman, I think. It's I'll grab it. Give me a second. Let's see how old it is. There it is. Design of Everyday Things. I read this, I don't know, 20 years ago probably. How old is it? It's from 1988. Okay? 88. Read this. This guy knew in 88 more than 90% of the guys who design UIs nowadays know. This is about, like, as you can see, it's about physical things as well. Like it's not about it's not only about UIs, because it's like there was no not like you can have like examples like this. How do you design door handles to make them obvious? And like still there's so many doors who get this wrong. Like how do you have affordances that are like that say push me, like all kinds of like old stuff, okay, whatever. But he also talks, I think it was this one that also talks about UIs. Maybe it was a different book. Again, it's been at least 20 years since I read it. But there are these fundamental things in UI design that we used to know, definitely in the 90s, probably in the 80s. And people who design, like who have the core job of designing the settings of your operating system. This is not some random website. This is one of the 3 big operating systems that we have. And the designer of the core elements of the user interface of like one of the 3 big operating systems has no clue what they're doing, obviously, like because they lost the plot on all. Like there's so many examples of things that got worse with the UI design that this is macOS Sequoia. And this is already old. Like I refuse to update. But I don't know, 3 or 4 versions before this one, they introduced a new UI. And every single change they made things worse from a usability perspective. Every single one. So I'm lost for words. I don't know how people like. How can we lose so much institutional knowledge? It's written in books. You can read about it. It's not like, oh, the library burned down and we don't know what their ancestors knew. Like this is within a generation, we've lost knowledge that people had that are still alive, that have documented it, they've written about it, and the next generation just doesn't know it. Like how the hell? Did I mention Linux? I just said one of the 3. It's Windows, macOS, and OS2, obviously. All right, anyways, let's start working on things, actually. I got sidetracked slightly. We have the master. Okay, this is gonna take forever. I'm sorry. It was only half forever, not that bad. Okay, now it's gonna take forever. I should have done this before. Fork. Okay, whatever. We'll switch back to this one. This is like switching, like I just threw away gigabytes of data and now I'm checking it out again. We rebase this here, which takes forever. Yeah, this is not even about Electron or something. This is about just core UI principles. Like you can implement them in Electron if you want. It doesn't really, it does not matter. Before I unstash, let's see if this compiles now. Yeah, looks good. So while this compiles, I'm gonna do an unstash to get our new LVM builds. It's gonna take forever. Oh, this is still my, okay, yeah, I have a debug build of LVM. You're gonna see a lot of this. This is tracking one of the core stupidities in LVM. I tried to optimize some things, and I was like, okay, let's update to LVM 22 first before we do this. Seems like I was able to put a crash in there. Doesn't matter. Does not matter. Let's check out a version, because I don't have the compiled version of the compiler that doesn't have this in it. And if you want to do performance comparison, we need a current version. So let's go to I have it checked out somewhere. Maybe I don't. If we do a full checkout of the compiler, it's going to take a while. What do we do here? Let's cheat. Yeah, let's cheat. We're going to go here, and I'll just, give me a second. I go into high security mode. I'll check out just the binary directory of the compiler, because I have that omitted for size reason from my git svn fork. So we have the current version of the release compiler built against LLVM 21 without my debug changes. And then we can see how long it takes to compile Sokoban with that, and then we'll build a LLVM 22 version and test that. Hey, Pravlinosc. Oh, my Polish is rusty. Which VM are you using to emulate Windows on Mac? I'm not emulating. This is a dedicated Windows machine that sits underneath my desktop, and I just remote desktop into it. I'm sorry, I'm Windows apping into it. How could I say remote desktop? Because as you can see nowadays, it's the Windows app, which is a totally sensible name change, which shows you that also no one with any competence is at the helm anymore at Microsoft either. Rhizoma says, did you say that the items you find by searching by typing are not showing the path of where the item lives in the UI? Yeah, not enough. Like instead of as you saw, it just filters so you don't know where they are in the list. So you would still have to, since they only show the matches, you don't get it. Of course, I could remember the name, clear my filter, find the thing in the list to see where it is, and then click on it to see how I do it without searching. That would give me, you know what I mean? That would work, but that's so far away from teaching people. I thought it was in design of everyday things, but there is this core concept of if you have shortcuts or if you have power tools that let people navigate things, they should teach them. Like old macOS did this great. I'm not sure, I think they still do that, right? Yeah. So this is, I don't know why no one has copied that from macOS. They had that for at least 20 years. It's such a perfect feature. Let me show you. Okay, let's say I'm in the Finder and I don't know how to change the font size, okay? Oh, I don't know how to say that in German. Maybe it doesn't have something. Okay, let's go somewhere else. Oh, in terminal, yeah. Okay. Let's say I'm looking for. Did you see this? This is such an awesome feature. Let's say I want to. I want to see how to make things larger. So I'm looking for größer, which is larger, literally. Okay, I was looking for text. Found a few things. So this is a system feature. This is not a feature of this particular app. This thing is a system feature they built into macOS. If you have a native menu bar on macOS in your app, you get this search, and I can say text, and I get all the entries in the menu that match text. And if I hover over them, you see that? Or if I just to the keyboard, it shows me where in the menu they are. Okay? It opens the menu and it puts a big blue arrow to where the item is. I can just, from here, I can just click this and press enter, like select this and press enter to trigger it. I don't have to go there. It is a shortcut, but also it teaches me where the thing is. Okay? If I say größer because I want to increase my font size, I go there and I see, oh, it's in Darstellung, which is like appearance or something. And it's here. And I also immediately discover that there is a default, like I can say reset to default. I say bigger and smaller. I see the keyboard shortcut next to it, etc. Okay, this is discoverability. And this, if I just care about make it bigger, I can just press down and enter and it's fine. Okay, but I also see the context of where will I find this next time. Okay, so if I don't want to type every time, or if I want to like see what else related to font sizes there is, I have the context. Okay, this is the best of both worlds. I have a quick action menu, but it teaches me where the thing is. And this is Apple at their best in UI design 20 years ago, probably. I'd have to calculate when I switched. So when I switched to macOS, it probably wasn't 20 years ago. It was 18 years ago or something. Maybe it's 20 by now. Yeah, between 18 and 20 years ago. This existed already, okay? So they built this core feature in 2 decades ago. It's fantastic. This is the level of UI design that Apple understood 20 years ago. It's perfect, okay? No, it's not command palette, cute math. You missed the context. Command palette doesn't give you this one, okay? It doesn't teach you. Command palette does this part, okay? This part is what a command palette does. This one, it doesn't give you. Hey, I show you where the thing is in a persistent way. Like command palette is always for typing. Yeah. So this is command palette style. This is better. This combines command palette with like persistence, physical persistence, like persistence in space. And persistence in space is necessary to develop muscle memory. And this has existed for 20 years. No one has copied it as far as I know. Oh, Togglebit raids us. Hey guys, we wanted to do something about LLVM. I'm just ranting about UX design right now because it maybe like this is probably, maybe it's more important for me to teach people about UX design because it seems like all that knowledge is lost. Object persistence, etc. How's it going? Yeah, it's good. I haven't streamed a lot recently because I work mostly on things I can't stream for legal reasons. So I've been pretty inactive. But I'm trying right now. Like I have an hour or two before the kids come home. So I thought this is something I could stream, and I started streaming. That we haven't even worked on it yet because I got so angry about how bad UIs are nowadays. So we're talking about object persistence and like the absolute killer feature that macOS has in all their menus, etc. Yeah, so this is a key. If you can build this, if you build UIs in any ways, if you can focus on making things persistent so that people can develop muscle memory, like also, this is a classic in UX. Like you've probably, if you have read anything about UI design or UX, you know this one. Like how big is the menu on Windows? Okay, is there even an app that still has a menu? Like they've got rid of that because it's uncool, or I don't know. Do we still? Okay, yeah, this is like this one doesn't even have a menu. This one doesn't have a menu. Do I have any app that I regularly open that has a menu? Give me a second. I'm not sure if I can open that browser without violating an NDA. I cannot. Okay, give me a second. Let's close all these tabs. Okay, let's open a new one. Doesn't have a menu. Awesome. Okay, is there any app in Windows nowadays that still has a menu? File Explorer. Yeah, I can't open File Explorer because I've used File Pilot as a replacement. So if I press Windows E, it opens another instance of File Pilot. which is good. I want that, but it means I can't show you File Explorer. Visual Studio. Visual Studio. Good point. So let's open Visual Studio. Yes. Okay. Question. How good do I have to be with the mouse? I know that sounds ridiculous to pro users, but how good do I have to be with the mouse to hit that menu? Like, how big is this extras menu? It's like a couple of pixels, let's say, how many? Like 50 pixels wide and like about 50 by 25. Okay, so I have to navigate within, oh, it's even less because up here it doesn't work and down here it doesn't work. So it's less. So I have to hit 50 by 18 roughly if I want to click here. Okay. Okay. How big is that menu here? Let help menu, for example. How big is it? It's let's see, do it exactly. Okay, it's also about 60 pixels wide. But how high? It's infinitely high because I can slam my mouse to the top and I hit it because it's at the top and I can't go higher. And important, its action region goes to the to pixel row 0. Okay, so I can't overshoot. Same if I want to hit the system menu. Okay, it looks like it's offset from the corner, but it's not. Like if I slam my cursor to the very end and click, I hit it. Okay. It's infinitely, like this button is infinitely big. I can click here, I can slam it to the top left and click, and I hit it. And this is why the menu is at the top on macOS, and this is why this is good. It makes it much easier to hit it. If I wanted something from the menu, I slide my mouse to the top, and I just have to navigate left, right. I don't have to navigate top, bottom. And like these are things that Apple knew 20 years ago. Just one example of UX differences. And they've lost all of it. Okay, but let's actually get into let's do the things that people are maybe here for. Let's do the LLVM update. Can you press Alt? Oh, sorry, Talbot, I didn't see that. Can you press Alt and get a menu? I know you can do that on some. Oh, see, Fork has a menu. I could have done this. File Pilot doesn't have a menu. Yeah, I know some now show it on Alt, but none of the things I use do that. On the other hand, they fucked up Liquid Ass so much that I've moved from macOS to KDE and Genji. Yeah, no, like Apple has lost the plot. There's a reason why I am on a many-year-old operating system. Like I'm on macOS 15. I think 18 is current, so I'm 3 years behind. There's a reason for that. I was forced to update my iPhone to the Liquid Glass Nightmare because I needed to check, I think it was a witness bug on iOS that was only happening on Liquid Ass. So I had to update my iPhone and I regret it. Everything's slower now. But you have to move your mouse a lot if your window isn't full screen. Nope, not true. This is not a full screen window. The menu is still at the top. It doesn't matter. You have an accelerated cursor. So whether I have to move it here, this is way harder to, like, it's harder to navigate to this part than to navigate up here because this I can just slam the mouse and I'm there. Like this is, it's closer. It's harder to hit than this. Hey, Boydmean. Hello. Thanks for the subscription. Yeah, literally have to be pixel perfect to resize some Windows and macOS nowadays. Yes, and on Windows. And on Windows, it's often worse because they sometimes don't even give you an indicator anymore when you, like this is, you used to have what was called Chrome. Like, I don't know if you guys know that. The thing around your window that's not rendered by the window itself used to be called Chrome. And every window came with Chrome. You know, all the old, if I say path, this one still has it, kind of. You have the, no, see, like this resizing, oh, you can't resize this one. That's even better. Oh, that's even better. You used to have a big thing at the top that you can take to grab the thing and shake it until it gives up, okay? Most apps don't have that anymore. Like I love File Pilot, but try to find, okay, I can click here to navigate it. Okay. Oh no. Oh, I forgot. I forgot that Windows is so bad. If I shake a window, everything else disappears. Such an anti-feature. Whoever designed that is fired. But if I want to now, I can't click here. I can find the few pixels between the menu and I can click here because there's no, oh, I hit everything again. Windows. Here I can, okay, there's some empty space because the menu is not that big, but the bigger the menu, the less empty space you have to drag the thing around. This is all things that got worse with every new UI design because they got rid of the Chrome. It used to be you had a thick border that you can take and drag. Like look up on old Windows, I don't know, 95 UI, and there's plenty of things you can take to drag. And this has all been eliminated. Our screens got bigger. Everything we want to touch got smaller. It's not fun. Would you be interested in doing your own UI framework? Nope. Nope. We have plenty of UI frameworks. The problem with our UIs is not that we don't have enough UI frameworks. Oh, another raid. Wow. Hey. Hey, guys. Hey, Kuvi Man? I don't think we've met. Thanks for the raid. Hey, how was your stream? Did you try the tiling of Windows? I have not. I use the split screen thing from time to time when I don't know, what I do quite frequently is that I take my shell here and have Wim just on the side and have that. If I need to switch back and forth a lot, but usually I just alt tab between the two. I've not done any other tiling. Super left click to move and super right click to resize on Linux really useful. Okay. Maybe you should do a little UI talk, Mr. Luba. The thing is, I don't feel like it warrants my knowledge warrants a talk. I have nothing new to contribute. I'm just regurgitating things that I have learned from people who actually know this shit over the past 20 years. Like, there's nothing new in anything I say about the macOS menu or about object persistence and teaching people, like, having ways that people can muscle memory things and not taking things out of context and keeping the context and having things animated so that people's, like, their eyes can track where things come from. Like, that scrolling jumps on Windows is so bad. Like, this jumps, okay? For small jumps, it's fine. For big jumps, you have no idea what's happening. On macOS, everything animates smoothly. It's not because it looks fancy. It's because it helps your eyes to track where things are going, where things are coming from. Makes sense. But all of this knowledge, I have nothing new to say here. This has been documented. This has been, you can read it in books. You can watch it in talks. All of this is known. Why should I talk it again? Like, nowadays we have YouTube where everything is persisted forever. Doesn't make sense for me to give a talk about UI design and make it like, I'm going to make it worse than all the great UI designers that are out there. I hope they're still out there. So, yeah. Using a Windows VM on Mac? No, this is remote desktop into a dedicated machine under my desk because we need to do things on Windows. I'm not a primary Windows user. I use it for games sometimes now that fewer and fewer games appear natively on macOS. And I use it for work on John's games because they're Windows games primarily. And like, if I need to work on the Windows version of the compiler, I need Windows. That's why I remote desktop into a Windows. Yeah, that you have to, like, ultrascientism is right. One disadvantage of the macOS menus is that you have to switch, like, if I now want to, I have, like, okay, these are both terminals, but if I have a, let's see, if I have a Finder window here and now I want to interact with the menu of the terminal, I have to switch to the terminal again. See, my menu at the top changes depending on the active app. And this is sometimes kind of annoying because usually you want the menu of the app you're working in, but it could be that you have switched focus and then you wanna, like, you didn't realize you switched focus and you wanna go to the menu of the Finder, but for some reason this one, like, I see both of them and I don't realize that this one has focus and now I wanna do something in the Finder and oh, it's the wrong menu. Now I have to tab to go there. Yes, that's a disadvantage. And well, it's all about trade-offs. Which program UI do you consider state of the art? State of the art is okay. This, nope, wrong. This menu is state of the art. Okay, this is state of the art. It's terrible because the state of the art has degraded, but this is state of the art. You probably mean what's best in class? Things from 10 years ago, probably. All right, let's do the thing we actually came here to do. So I've downloaded the binaries, like the binaries of the compiler. Yes, so I'm just gonna take Jai and copy that into my bin folder. Yeah, like shout out to FilePilot. I love FilePilot. Fuck Windows. Like every time I move away, no. It's so bad. Okay, shout out to FilePilot. It's great. I love it. I use it every day. It's worth every cent. It should be more expensive, honestly. But it had a bug for a long time, and I've reported this to Vyacheslav, where it doesn't update anymore. Like I copied, like let me show you. I'll take LLD. I pasted. Oh, that's already in there. Okay, we don't need to paste that. Whatever, let's say giant mycos. I pasted, doesn't show up. For some reason, the file watching is broken on my machine. 9 times out of 10, I use FilePilot. I have to press F5 for it to show up. I'm not used to just pressing F5, but it's clearly like, this is stupid and it should be fixed. But otherwise, apart from that, like I love, like let's delete it. It's still there. I have to press F5 for it to go away. That's stupid. The shake, yeah, that's a Windows thing. It's the shake your baby. Such a terrible idea. Okay, so we have a Jai exe that we can use. I just have to use it now manually because if I just type Jai, it's something else. Projects, Jai, bin, Jai, source first, Jai, final. Let's do some measurements. Am I running on the latest version? I think I am. Whenever I see him on Twitter, yeah, 07 from February. I think that's the latest. Okay. Also witnessed the amazing speed of LLVM. We're building a release build of Sokoban. It's about 300,000 lines now. And we're still waiting for LLVM. Like, this is not Jai being slow. This is LLVM. I know which one it would start. I know exactly which one it would start, but I want to start this particular version right now. So it took 58 seconds, 59 seconds almost to make a release build. Let's do a second one. And you know what? Let me open numbers. Let me close everything that's private. And let's open a new spreadsheet. And so we have LLVM 21. Oh, let's do that. LLVM 21. We have Sokoban final. And it's 5879. Nope. 5879. And second run, 5793. Let's do one more. And yeah, I mean, it would be fine. Like, I would be fine with LVM taking a minute, okay? Like, we do everything. Like, this 1.1 second thing, okay, is the whole, like, this is everything. This is, of course, parsing, type checking, bytecode generation, etc. It's also like compile time execution and generating thousands of lines of code that then get compiled again. Like, everything is in this 1.1 second. And then this crap, this 56 seconds, that's just LVM doing the final, like the optimization pass. I would be fine with it taking a minute if it spent that minute actually optimizing things and making things really, oh, sorry, I forgot to change, my bad. So this, I'm talking about this, like this 1.14 seconds, this is, it says front end, but this is more than just regular compiler front end if you think about Clanger. So this is like including bytecode generation, this is including compile time execution, like especially Sokoban has like lots of bytecode execution at compile time where we generate more code and do meta programming, etc., etc. Okay, so it's 200 right now. It's depending on how you count. It's 260,000 lines or 172,000 lines. Takes 1.14 seconds, and then LVM grinds for 56 seconds. Would be fine if this 56 seconds were spent productively, but I've profiled this. These 56 seconds, there's so much stupid stuff in there. Like, one of the things that's so slow is the thing you saw me probably up here. You saw this, okay? This is the bug output I added after a profiling session. This is LVM putting thousands of items, like you see this 7,000 showing up here many times, so did this many times. It's putting thousands of items into a visited set, where on the visited set, it says that this is for small, like it's optimized for very small sets up to 32 elements, okay? And it's in the documentation of the thing they're using. It's called small pointer set. And they put thousands of items into that thing over and over again. So it starts with an element count of 16, gets doubled every time it runs out of size. So they put in 16 elements, it overflows, put in 32 elements, it overflows, puts in 64, you get the idea. Up to 7,000 in this case. And they do that over and over and over again. Sometimes with 7,000 elements, sometimes with 30. Like the highest I found after a bunch of mitigations we did a couple of versions ago, up to 30,000 elements. And they do that over and over and over again. Why? Because they're building a call graph. There's a thing in LVM that's called the lazy call graph. We're going to step into it later, if we still have the time after all my ranting. And they built this lazy call graph for every function you're compiling. And if that function happens to touch a big value can be everything in LVM. In our case, it's the type table, for example. We've already split the type table in smaller chunks, but nonetheless. If there's any function that touches the type table in any sense, so it does anything with type information, LVM thousands of times grinds through the type table and visits every data chunk in the type table, which is every value, every pointer, to see if there are any function pointers in there that might be part of the call graph of this function. There's no way to prevent that. There is no way to flag something like, no, there are no function pointers in there, or nothing here gets called, or whatever. No way. And it does that over and over for every function, even though it has visited that type table for the previous function. It throws everything away, redoes it for the next function, over and over and over again. And this is a large chunk of what is done in this 56 seconds. It's memory trashing. It's rebuilding the same graph over and over again. I've profiled it. I thought I'm going to go crazy. And of course, you don't see it. If you look at the code, it looks fine, because what the behavior I'm describing is like 10 layers deep in abstractions. Like The guy who did the, oh, we need the call graph updated code has no idea that that's happening, probably because it's happening 4 layers underneath him. And the guy who does the whatever pass, pick your pass in the pass manager, where did we crash with my debug changes? You can see it here, yeah? This is the update call graph and analysis manager for pass. Okay, this is just, you do something, you write the inliner pass for the LVM optimizer. And if you do that, you need to update the call graph. And because it's lazy, because, hey, we do things lazy, that's efficient, we only do it if we need it. So we have this lazy call graph that we don't persist because we only build it lazily. And we do this over and over. And instead of doing like, okay, you have a call graph, there are subgraphs of that, they're going to be persistent across, like if you have 10 functions that all touch the same data, you could share that subgraph, okay, that you've persisted for constant, you have constant data that you don't, not touching, that you can't modify as part of the optimizer. Build your freaking call graph for that and reuse it. That would cut the compile time we have for LVM probably in half. Can't do it. Like, I would personally patch that in if I could, but the way LVM is written, the way the abstractions are structured, the way everything's hidden between generic, like underneath generic operations, you can't do that. You can't put that optimization in to fix that shit. Yeah, okay. Today is a ranty day, as you guys can hear. Okay, we have a final 5802. Okay. And then the problem is you would have to not just touch hundreds of files, you would have to rewrite large chunks of LLVM because everything uses these generic systems. You can't say, nope, you know what? Let's reuse part of the call. Like, there's no thing, you can't put this anywhere because everything's just operating on generic value sets. And like, there's no place to say, oh, let's build a subset of the call. Like, just doing this in the LLVM codebase is an insane endeavor. Whatever, I'm grumpy, as you can hear. Okay, why do I not see? Oh, it's updating. Okay, let's do LVM 22. So I have this lovely list at the top of this. What do I need to do to update LVM to a new version? I did this, we did this, we did this, we did this, we did this. Compiler project files need to be updated on Windows because we're here. Repeat steps 5, 7, 9, 10 on all OSs. So we did this. We have to do this. So we go to the project file and we look for LVM 21. And you know what? We look for the whole thing because then I can replace it easier. Okay, and we say LVM 22.11, I think is the current version, right? Yes. Bam, 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 bam. Done. Next. Do whatever is necessary to make the compiler compile against the new LVM version. Let's do that. It should be nothing necessary because I already did that on macOS. Maybe we need to link against a different library because they shifted things around, but this shouldn't be too hard. Did I report this to the LVM guys? I'm so cynical about these kinds of things. I see no reason to report this. Like, chances of, I'm not sure, I haven't looked at the LVM bug tracker. Let's do that. That's a fun exercise. Let's go to their GitHub. So if I go to LVM 22, okay. Let's see, LVM project, issues. They currently have 28,000 open issues. What do you think, like, what kind of impact is it gonna have if I say, hey, your shit is slow? Like, issue 28,087 is going to be, hey, your shit is slow. Like, do you think, like, I mean, I think it's just a waste of my time. Yeah, imagine the discussions you'd have to go through to push this change. Like, no way. Like, Again, I would have no problem just doing the change. Like usually I'm pretty disillusioned with, like, I don't expect, I think this is the entitlement thing. I never open up issues, never, like as in never. I can't remember doing it, is what I want to say. I can't remember opening up an issue on a open source project without also providing a patch. Just saying, hey, this is broken, please fix this for me, I think it's unproductive. I think expecting maintainers to fix your issue is a problem why so many maintainers are burned out. If you're using an open source project and you have an issue with it, I think it's on you to dig into the code, figure out why it's wrong, and offer a suggestion how to fix it. That's my opinion. Like if I find, like, it's usually when I have a bug in a library I'm using or a problem or something, I just fix the bug and like I fork the thing, fix the bug, and then I open a PR where it's like, hey, here's your bug, here's how you can repo it, here's the fix. If they care and they merge it, perfect. If they say, ooh, but you didn't adhere to our architecture and philosophy, well, then I'm just, okay, then don't merge my pull request and I'll maintain my fork, whatever. Maintainers and others should know first there's an issue. Yeah, but do you think that maintainers, if I open an issue and say, hey, this is slow because of that, do you think it's going to get noticed in 28,000 items? I don't know. So I missed something from Cute Math. Is there a lot of stuff on the to-do list before work on the X6 backend can start? You mean before optimizing? Dude, my to-do list, it's not funny. Not funny. Right now, like currently, like I can't speak for Thekla or John, but currently the priority is getting the game out. And I'm pretty sure that getting the game out has higher priority than pretty much everything. Okay, let's continue. And let's stop ranting. Let's continue on our track. Is ARM ASM supported? What does that have to do with UI, state of the art? But hey, BFG rocks, welcome. Okay, so we have a missing symbol. That happens usually when we update LLVM because, oh, by the way, this is also, we'll keep this open. This is the pass manager. This is where the insanity happens. This is the thing that probably caused the crash. I added some stuff here. This is the outputs we saw when we did LLVM 21. Where I just spam how big the visited set is. Okay, whatever. If we go to LLVM converter. So there's somewhere here, there's this huge list of libraries we have to link against. And there's something new in there, obviously, because we have a missing symbol. So the way I do this normally is I have this utility find symbol. And that works cross-platform. Like, of course, there are things where you can dump symbols from object files, but sometimes I have to do this in a cross-compiling scenario, whatever. I wrote this find symbol. It's in Jai. It ships with the compiler. So I usually, if I can find in this mess what the symbol is actually called. Yeah, this is the unmangled name. Give me the mangled one, this one. Oh, I can't copy here. Another thing that macOS got right and is making worse now is on macOS, you can basically select any text anywhere in any UI and copy and paste it, okay? If I don't know, how do I open some error message here? No. Almost everything can be selected. Okay, I can't, labels, no, but if you have any message or any text, I can usually copy and paste this. Windows, nope, I can't select this. Too bad. You wanna do this without typing? Your fault. Why do you care? No, I didn't want to. Oh, curse you. How can I see the actual? There we have it. But you have to know that you can do that. Let's give me the name. Calculate binding info builder. I'll take just this chunk. I say find symbol. And then I just give it sub. Oh, we're in Sokoban. Sorry, wrong. Find symbol. I give it that symbol in quotes to be safe, and I say path sub LVM 22 Windows release x64, and we throw away the errors for now. This one definitely doesn't work. I'll usually pipe it to an error.txt, and I'm good. And here we see it's in LLVM frontend HLSLib. So you see, this is quick. This is how I find symbols nowadays. There's probably a better way, but this is how I do it. And then we just do this, and we do this, and we paste it, and then we say, maybe because we're a good citizen, we do a sort. And that's it. And then we try again. Is WebAssembly going to fix the Web Dev world? No. And there's an excellent Wukash podcast episode that explains why. I forgot who it was. Let's look. Let's give Wukash a shout out. I usually do it on Apple Podcasts, but I know he's on YouTube. And that's probably more accessible. And of course, YouTube forgot my user again. Of course, because it's so hard. We talked about object persistence, right? If Google at some point would manage to remember which user I'm using for which of their pages, that would be awesome. But I think that's too much to ask. There's Wukash podcast. Wukash podcast for insiders. Let me show you Mr. Wukash podcast. And we have... Is it not in the title? Yeah, it was with Ben Wisnes. Yeah, this episode. Let's be nice and copy it for people. If you want to know, like, this was a fantastic episode. I was not aware of Ben Wisnes before. Like, he's the guy who like, he's the handmade community or maintainer, chief, someone, I don't know. I've never been part of the handmade community because I was too time poor and far ahead in my career to participate. But he seems to be well known in that area. I was not aware of him. Very interesting episode. I like the guy. And he goes into detail about what OASM does and doesn't do and why it won't fix certain things, etc. It's a really good episode. I can recommend it. Okay, so we compile. Hooray! We have a debug build. Let's do a release build. And since we have Wukash podcast opened, no, we don't want that, and we don't want ads. We want... Did he ever release these? No? Oh, that's a shame. I don't want to publish things he hasn't published, but there's an awesome sketch we did at Better Software Conference 25 about Wukash podcast. It seems like he hasn't released that. I have to ping him about that because he has posted it on a private channel and it's hilarious. Interesting ad. Yeah, I have disabled personalized ads on YouTube and Google generally. So I get whatever they get if they can't. Like, I get all the ads that they just spam across the whole, like if they don't care who's watching, if it's just based on the channel or something, I get these ads, and it's so weird. So weird the kind of ads I get because they're of course totally unsuited to me, and and B, you see like who posts indiscriminate ads, or ads indiscriminately, I would say. Yeah, exactly. It's a programming channel, so they assume I'm male probably and maybe young, and so I get ads for body deodorant and I don't know, lots of like spammy investment advice and I don't know, crap. Okay. We have a release build of the compiler. Let's give it a go. Let's do it. This is a debug compiler, debug build, just to see if things compile. And also we can do the same here. We should run, because one of the steps, if we follow this one, it says whatever's necessary, we did that. For major versions, yes, we need to do that. That's going to be sadness time. We're not going to do that right now. Run all tests. Oh yeah, we're going to go to ABI first. Make sure that the ABI is fine, but that should be fine. I'm going to update this. This is this line. We're not going to delete the old one. Bindings generator, we can do that, but we're going to be sad, so I'm not going to... let's do just... it's probably the same on Windows, but... shall I? No, let's separate these two. Let's see if LLVM works for us. So we're going to do this the following way. We're going to have a lot of changes. Where's my changes? Oh yeah, it's updating. We're going to have a lot of changes in... So libclang has updated, obviously, but there should be like a gazillion... Nothing? What? Is this ignored? Like there should be... Like these should be around. Okay, let's do it by force. Git add sup LLVM 22 win release x64. It's not gonna do that because it's ignored. Yes. Interesting. Let's see what git ignores we have. Oh, okay, we generally ignore. No, but this can't be the thing that ignores it. This wouldn't ignore it. Are you lying to me? There's no other git ignore. How can this one be ignored by the... This is the only thing that... Oh, maybe we have a more generic sup ignore. Nope. So these are all... I don't understand how this can be ignored. Okay, let's do force add, of course. I expected that we have to do force add, but I don't understand why it would be ignored. Because none of these rules tell me that this path is ignored. Hey, Nafonso. I'm doing well, except I'm ranty today. Okay, this takes forever because this is like gigabytes of stuff. And this is the release build. Like the release with debug info is, oh, it can show you actually. See how bloated the LLVM is. Just like it's so it's beyond imagination. The release build takes 1.1 gigabyte. That's sensible, right? Release build against the debug C runtime 1.2 gigabytes. Sensible. Release with debug info. Yeah, this is the same as this one, but with debug info, 13 gigabytes. That's 12 gigabytes of debug info for those who are counting. Same here. The build folder. The build folder for the x64 build is 5 gigabytes. Okay, whatever. The build folder with debug info is 81 gigabytes. And of course, you need two of them because you need debug CRT and not. So this is 160 gigabytes of build stuff. And I have to keep that around because if I want to do partial rebuilds or something, I don't. If these folders are gone, I'm waiting for hours. So I have to keep this around. So that's 150 gigabytes of garbage that's living on my thing. Of course, that's just 22 because we have the same for 21. So we have another 150 gigabytes of garbage here, etc. You get the idea. That's LVM. Okay, so we've added win release blah. We need to do the debug info CRT variant. Well, with debug info, nope, not true. We want release debug CRT. Do you know if this LVM, that's what we're testing right now. That the whole point of the stream was to see if it got faster. But rants have slowed me down. I'm sorry. Okay, so we add this one. Oh yeah, we're adding something. We can't add while we add. That would be mean. Any questions, generally, guys, while we wait for Git to add gigabytes of stuff? Oh, it's done. No questions. So we're gonna do this one, which means we're gonna add Clang. Old Clang, 97 megabytes. New Clang, 147. That's unfair, though. That's not quite right, because this is with debug info, so we're not going to check that in yet. Because I first built the pure release build, and then I built the release with debug info build, so these got copied over from the release with debug info build. That's why it's so big. Same for this. Same for this. Okay. Add most, because I'm purposefully not adding libclang because I'm revert that, because I know there's a regression in libclang, and if I keep that binary here, lots of our tests are going to fail. I cannot give you a ballpark because A, I haven't looked at RAM usage of the compiler. B, it's not been a priority for us to look at the RAM usage of the compiler. C, if LLVM was written in Jai, it would not be written the way it's written, so I can't tell you how long it would be. It need to compile. Like, no idea. No idea. And honestly, like, we haven't tested it in a project this size. Like, the biggest code base that Jai has compiled that I'm aware of is Sokoban, which is, like, depending on how you count, between 200 and 300,000 lines of code. Okay, so we have something. We can now say Jai R. Do we say anything about the... No, we don't say the LVM version. Okay. Let's run the tests just to make sure that it actually... You know, let's do it in debug build. This is going to take forever, unfortunately. Because we have to use the LVM backend, obviously, because tests. It seems like I have something lying around that's called test. Nope, I don't. What the heck did this do? The test command runs and does nothing? I wonder what executable I just ran. Okay. And here we're going to prepare the following. We're going to do a release build, use the release compiler to the debug build of... Oh, I should have measured the debug build times of the old one. Let's do that as well. Let's see how fast debug builds are with the old compiler and then with the new one. So we need more columns here. So 21, so go on final. So Koban debug. And then we do LLVM 22. And then we'll see. But let's run the tests first. No, in 10 years, no one's going to have any RAM at all because it's going to be too expensive to buy any RAM. This one is fine. This is a, like this test failure that came by. This is a regression. This is a repro for regression that I have still lying around here. What if 22 is slower? Then I don't upgrade for now. But I heard it's faster, so maybe it's faster. Someone mentioned that Odin got faster with the update to LLVM 22. So 20% faster. If LLVM 22 is 20% faster than 21 for our code base, I will... Apart from being very happy, what's something I could bet? That's reasonable. Eat some chocolate. That's a good idea. Yeah, that would be terrible because I don't have any chocolate that I like right now. So that would force me to eat some terrible chocolate. Okay, I will eat some chocolate if LLVM 22 is 20% faster. That's a good bet. No way in hell it's going to be 20%. Like, if it's 5% faster for our use case, that would be awesome. I have already recompiled all my tools with the new version. No, I don't like the chocolate we have. Like, it's not. This is me eating chocolate if LLVM is faster is it's punishing, not a win-win. Okay. Okay, seems the tests run fine. Good, perfect. Good. Now let's do old compiler debug build. So LLVM 21 release compiler debug build of Sokoban. Let's discard the first run because we just flushed all the like file system cache, etc. with running the tests. So it didn't get any, or it got a bit faster. So we have 6.13. 6.15. Interestingly, the front end time is way slower now. So the debug build must do some more things in front end. Oh, also, yeah. Do you see this? Like in debug builds, the number of lines we process is it was 172 before, now it's 236. So it's 30% more, roughly. Like ballpark. Okay, we have 3 runs of Sokoban debug. Let's do JIR source. First run doesn't look good, but it's a new executable, so let's give it some time. Let's discard the first run. 646, so that's slower. Surprise. 651. Bah, 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 bah. You have to migrate to using the new enable global cell thingy. If you can point me towards that. I'm sorry, I don't know. I'm not sure if you guys have ever read the... So the thing, I don't know, how do you know these things? Like, Ryuk, if you could entertain me. Because the thing I normally do, okay? If I'm upgrading LLVM, I show you what I do, okay? I go to LLVM 21. I go to the change log, okay? And here you have, hey, this is my favorite. Non-comprehensive list of changes in this release, ... You have changes in the LLVM IR, okay? Infrastructure, LLVM. So I just scan this. Okay, Arch backend, blah, blah, blah. I don't care. PowerPC, RISC-V, doesn't, like, okay, here we had some breaking changes before, but this looked harmless, so I skipped over it. Backend changes, C API. I looked at this. Okay. Seems harmless, okay? Doesn't seem like there's anything in here that I need to do. Okay, we can use this, but we don't need to. Okay, maybe this is some, but we don't use that. Yeah, these have been deprecated, so I don't see any change in here. We don't use the LLVM tools. We don't use LDB. Other changes. Nothing in here. So these are also external open source projects using LLVM, a project. Like these release notes are so ridiculous. Okay, nothing here that tells you how to migrate. Nothing. There's nothing about, oh, we completely changed how we distribute LLVM. Okay, because they did that. Not mentioned. Like, usually, whenever there were changes, significant changes to LLVM project, I never found them in the release notes. I don't know who. I'm sorry. I'm sensing another rant coming. You have to migrate. Enable global cell thingy. Yeah, if you find the article, that would be great, because I don't know how to, like, I'm not sure if they. How do people figure out what's new in LLVM releases? Because the release notes are not it. How do you know, oh, I should do this to get this benefit? Like, I'm sure there's been, like, because when I joined the project, we were on LLVM, I don't know, 12 maybe? Can't remember. So I'm sure that there are lots of things that we should do differently with new LLVM versions that I just don't know, because I don't know how to know them. Shall I just read the mailing list every time? Everything? Like, how do you... Usually the release notes are for these kinds of things, but the release notes of LLVM are so poorly maintained. Yeah, more ranting. Okay, so we're slower so far. Let's try, while we wait for Ryuk. Enable global cell. I'll just Google that, okay? Let's see what that turns up. Enable global cell. LLVM 23. Yeah, I don't know how that, like, again, it doesn't give me any actionable thing. And how would I know that this happened? If I read the changelog, how would I know that this happened? I'm not sure how they... Again, I don't know how you're supposed to get information about new LLVM builds. Okay, first run, we're going to discard this, but it's 68. It used to be 58. So that would be 11, like 20% slower, roughly. Which sounds awesome, doesn't it? Oh, guys, no. Okay, this is unfair. Sorry, we're a bit unfair. Because we're using the... so maybe I'm doing... something like to LLVM. I'm doing them a disservice. We're linking almost certainly now against the relevant debug info builds, which will have, like, shouldn't be slower in reality, because the debug info is, okay, it will slow down startup maybe if the symbols have to get loaded, but it shouldn't affect runtime actually. But you never know. So we're gonna just do this to make sure that we're not linking against the relevant debug info, because it will make the binary bigger, etc., etc. So that there's some drawbacks to that, but it shouldn't affect runtime performance. Like it shouldn't make it 20% slower just because there's some garbage that's also attached to the binary. It should have some constant overhead for starting, but that's about it. But you never know. So let's redo this with something that's definitely not linked against that. Uh, 625. It's a bit faster. 6115. Okay. So I think we got rid of, so let's take this as the first. 61. Okay. So we're back where we were. 607. That's faster than what we got before. So why is the debug info slowing down LLVM by 10%? 616. Or is this just random bad luck that they had? So it seems to be like this is with 3 samples. This is within measuring distance in the debug builds. Within measuring accuracy, I mean. Let's see what it says for a final build. Oh, it was global iCell, not global cell. So that's why we didn't find things. That's on me. Global, I think this is instruction selection, right? Okay, those results are not better. So this is from 24, should be not, okay. Global ISL. Okay, looks like this is Arch 64 as Xer said. How do I do that? What am I doing here? Is this supposed to be better? Because it's longer with global ISL. But like I love graphs without compile time, so it's worse. Compile time. Is this the pitch? Like, look, it makes everything slower by 20%. I guess I would hear the talk compared to it. Compile time. How did this become a word? Like, at which point did someone decide that middle end is gonna be a word that they're using? I heard it like I've heard this multiple times. It's the middle, guys. End implies that it's at the end. There's no middle end. Okay, we have, so I'm gonna discard the first run as usual. 5931 is at least not worse. Oh, it is worse, but it's not much worse. So I don't see 20% speed improvement. But maybe we need to do the magic Ryuk thing. We haven't heard from him, though, again. I wouldn't even know, like, are we doing anything with instruction selection? We have global ILCell here as a library. Ooh, maybe we should look at these options of target machine, huh? Okay, so we have 5910. It's not good. So target machine has an options thing. We'll have to find that. So the way I look at the code is usually this. Let's make it, let's cheat. Just so that this one is rooted. Sub LVM Why don't I get completion? 2211 LVM 2211. It's called project. No, LVM project. It's one of the changes with the new LVM. Dot source, I think. Yeah. And then we're interested in target machine, right? Now I've slowed down this pass a lot. 5970. Because I did other work. It's a bit unfair, but it doesn't look like we got any faster with the new LVM. Fast iCell is faster than global cell at I0. Okay. Yeah, the question is like, I'm fine with just enabling this for release builds or whatever. Like we can all like, no problem doing this selectively. I just still need to know how to do it. I didn't see anything in the manual, something how to enable it. But again, I think that I don't know where to look in the LVM documentation. Maybe it's something that's well documented and I'm just too stupid to find it. So if I say LVM enable global iCell, doesn't give me anything. Like, how do I enable this? You know what I mean? Like, there's nothing. Raw. We'll wait for this pass to finish and then we'll try to find the thing. 5931. Okay, so whatever they're claiming, like LVM is not faster. But maybe it is something you have to enable by hand. Could easily be. Maybe we have missed 10 major versions of things we could have done to make LVM faster. Then it could say that's on me. But how the do I find that? Like, there's nothing, like, you know what I mean? Like, you saw me, like, I read the changelog for every version. If they said, switching to blah in release builds makes it faster or something, like, you know, you get what I'm saying. Yeah, of course, I could go into the Clang source code and diff it with the Clang source code of the previous major version and see if that tells me something. But why is that? Okay, I'm going to stop here. Target machine. No header file. Okay, we have options in here. Where do they come from? Is it target options? It's target options. This is how I navigate LVM normally. If someone has a better idea, let me know. Target options. And we have fast iCell, enable fast iCell, enable global iCell. Okay, and we have documentation here. Fast path instruction selection, which trades away generated code quality in favor of reducing compile time. Flag enables global instruction selection. Okay, with no comment. Let's just try that, shall we? We're gonna say if not machine, we have LVM. Oh, okay, let's say if opt level is 0. Oh, this is not Jai. Then we're gonna do this. Luckily, I had this comment in our code. Otherwise, I would not even wouldn't even have known where to look for enable global iCell. Else, enable global iCell, and we're gonna do this just to be sure, because of course you can enable both, which is awesome. I love these kinds of options. I want it fast and global, please. just to be sure. Okay, and we're gonna say if LVM, I assume this doesn't exist pre-21, maybe it's, where do we define this? Yeah, the problem with like, I also use LVM for these kinds of, not L, I use LLMs generally for these kinds of research. The problem is, especially if it's something that's so rare, like how many people use the LVM backend and their options, etc. Like it's a handful of people. Then the chances you get it hallucinates so much about what options there are and how you enable things, etc. It's a nightmare. Kind of, well, that's what I use in my code base. I left a comment saying this got fast in LLM22. It's like target machine globalins. Okay, so use the C API, I assume. No yug. Yeah. So I think this is what we're doing. I just check where do we have pre? Oh yeah, makes sense. So we're gonna say this is not quite right. Hey, Valigo. Nice to see ya. Okay. Let's try that, shall we? So we give it the chance of being faster for debug builds and release builds. Maybe. Maybe not. Well. Okay, we'll discard the first round. We're not going to be mean. 673. That's worse. LLVM22. Fast. Global. So that's what? 673. So fast is slow. Yeah, 6.7, exactly. 6.7. My kids started doing that like a couple of months ago. $6.93. Yeah, that got way faster. I'm amazed. Maybe, you know what? Let's not be a dick about this. Just to make sure that we're not, like, maybe I've screwed this up. Well, let's not recompile. We'll do this afterwards. Let's see if the release builds got faster. Okay, Ryuk, do you have any other suggestions of what we might do to make this faster? Because so far I'm not impressed. Hello, 6828. You should rename to 67 as we just... Unable translate instruction call. Allocator proc. Well, that's not good. So much for global ICEL. Uh, Ooh, I have to stop pretty soon because I have to get the steaks ready. Let's see. This one should output fast and not global, just to be sure. Yeah, so we're fast and not global for all modules. And this one should output once. Yes. Okay, so we're using the right thing. Just wanted to double check that. But this is not good. Unable to translate instruction call in function allocator proc. Let's see. What's it called? I forgot. Compiler.jai IR output LLVM IR, not emit. Okay. Do we have a flag for that? We don't. Okay, so let's do this. So if we do debug, which is the default, I think, and LLVM options. No, not for debug, actually. We want final. And we have to do before optimizations, I think, because it just choked. Let's enable both. Wait, did I just... Okay, there it is. Before optimizations. Good, we can do that, right? Let's see. Oh, also RMRF build, RMRF source build. No, like, it's okay. I'm gonna repeat myself, but it's great that LLVM exists. It allows people to make languages that would have no chance of making an interesting and competitive language with any effort. It's great that it exists. It's such a shame that it has such a terrible quality of code. Like, not the thing it outputs, but the code of LLVM itself is awful, god awful. Like, it has all the object orientedness you can imagine, all the C++iness, all the let's abstract everything away so no one knows what they're actually doing, and use lots of generic algorithms to traverse nodes and reason about nodes, which I get why they did that. Like, I get it, but the problem is the code base is it's unbearably slow. There's no way to make it actually fast, like as in like how do I say this? If you follow Casey and do his performance aware course at computerenhance.com, you realize, like, our computers nowadays are so fast. They're unimaginably fast. No one has any idea about how fast our computers are, including myself. And you can get a lot of that speed if you just don't do stupid stuff. You don't have to be optimal. You don't have to be Fabian Giesen and like think about every single instruction you put in there to make like all the execution ports of all the CPUs you're going to target go as fast as possible, etc. You don't need to do any of that. You just have to not do insanely stupid stuff. And LVM is full, like the whole code base is chock full of all the things you shouldn't do if you want the program to run reasonably fast. Like you have everything in there, like pointer chasing, like trashing caches, like lots of allocations all over the place, like doing things in many loops that you should do in one loop, like everything you can imagine that you're trying to avoid if you try to make your program reasonably fast. Like it's all in the code base, and you can't get it out because it's so deeply ingrained in everything. And so LLVM is, I don't know, it's probably a factor of 1,000 slower than it should be if you actually did it in an efficient way. It's okay to defend LLVM to some extent. Generally, compiler stuff is hard to do really fast. If really fast, I mean like Cindy fast, like doing everything wide and operating on many things at once, etc. That's hard in any compiler, because syntax trees are by definition trees, and you kind of need them. Like you can call it sea of nodes. If you watch like Sam's talk from BSC 25 is actually a great introduction to sea of nodes, I think. But it's the same. You have lots of things that point to lots of other things. It's by like inherent in the problem is that you're basically always pointer chasing to some extent, and you have bad cache locality because the nodes get allocated as you parse it, and then you merge nodes or rearrange nodes or whatever, and so things move around, and they're definitely almost certainly not within contiguous areas of memory, and you have to have lots of informations per node, so they're generally too big to fit even in a single cache line, etc., 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 etc. So that's generally, that makes a compiler slow, as in Casey's definition of slow, as in like you're not gonna work in a 16 wide loop on 16 nodes at once when you do type inference or something. I wouldn't know how to do that at all. So you can't get that kind of fast, almost by definition. But you can at least try to not make your life deliberately worse by abstracting everything away like crazy, so that you have no chance of even seeing what's going on. Like if you look at the thing I mentioned earlier in the stream, like the lazy call graph implementation, anyone who uses that, whoever does the inline pass, they have, unless they profile it and step through it, etc., you don't even see the kind of madness that's going on underneath the abstractions, like the set trashing, etc. It's, yeah. Yeah, no, I understand why LLVM is the way. Like, if you watch, someone interviewed the LLVM guy. I saw a podcast with him. I heard a podcast. I never watched them. I just listened to them on Apple Podcasts. I listened to a podcast with the designer, and it was really interesting. And he explains how he did the LLVM project at Apple, and then how Swift came into being, and how he introduced Arc, like automatic reference counting, to Objective-C and why. And it was super interesting. And if you listen to that, you immediately know why LLVM is the way it is. As someone said in chat, like it started as an academic project, and then he basically was able to convince Apple to adopt the project, and then convince Apple to use it internally, and then did lots of, like, he seems to be great at politics in a good sense, as in like he knows how to convince people to use the things and to back his projects, etc. I forgot his name. You know who I'm talking about. Or if you don't know, Google, like whoever did the initial LLVM design. I'm so bad with names. But it's clear why it's so terrible, because he did it as the core architecture of LLVM was set up when he was a student. And like, if you look at the things that I did as a student, and he's probably way smarter than me, but still, like, if you're in your kind of first big project and you do the architecture up front, it's going to be awful. It's going to, like, this is something that should have been designed by a graybeard, like someone in their 50s who has done 10 different big projects, and then they start LLVM, and maybe they have worked in the games industry, or maybe or if John Carmack bootstrapped LLVM, then we would have something that goes brr properly. Chris Latner, yeah, thank you. But if a student does the core architecture of the thing, and it's great that he did it, great that we have it, as I said many times, but no surprise that the code is written terribly. And once you're down that path for a while, no one's going to re-architect the whole thing. You need to basically start a new project from scratch with someone you probably have to, it has to be your third backend before it gets any good. And then he did the same mistake with Swift. He achieved way more than I will ever achieve. So don't get me wrong. I'm not I would have done it better. No. But if you look at how it developed, how Swift got introduced and how, it's the first language he designed. And obviously you have all the problems in Swift that you have if it's the first language you've designed. You know what I mean? It's just, if he is so good at I call it politics. Politics is not quite the right word, but he's so good at convincing people to back the things he's starting that his first of everything becomes a big success. His first compiler backend becomes a big success, LLVM. The first language he designs becomes a big success, as in Apple adopts it as their main language, but it's the first language he designed. So he made all the mistakes that he probably did it better than I could have done, but if it's your first, whatever, it's gonna suck because you learn when you do your first thing. So, you know what I mean? It's of course the architecture of LLVM is going to be terrible. Of course Swift is going to have all kinds of fundamental problems in its language design. But that's a curse of success. If the first things you do with everything become super successful, then you're kind of stuck with that. So that's my gist on why LLVM is the way it is and why Swift is the way it is, etc. Without, again, not saying I could do it better. But it's if you look at my past projects, the first times I did anything is terrible as well. That's nature. All right. So we have the LLVM. We have this intermediate representation. It's going to be ginormous. What do we have? 1.7 million lines of code. Set file type text. Otherwise, Vim is going to die. When we're looking for allocator proc this. Let's see if we can find this. Oh, reasonably fast. Okay. Yeah, the difference is John, this is not John's first language, and he gives it plenty of time to cook. That makes it different. But of course, there's gonna be mistakes in Jai as well, of course. No one does a perfect thing. The question is, can you back out of it? Or are you stuck with your mistakes forever? That's kind of the problem. Okay, so in here, we have a call. In this function, we have a call. Oh, scrolling is really slow, obviously. We're going to do the following. We're going to make Vim's life easier. We're just going to take this one out. Okay, so we have 400 lines. There's a call in here. There's lots of calls in here. And one of them, it cannot translate. It's a lot of calls. How do we figure that out? Okay, I think the problem is I have to stop pretty soon, but this might be an interesting. So this one seems weird. I don't know, I know very little about LLVMIR, not enough to properly debug this, but to have that we have a tail call. I'm not sure what tail call in LLVMIR means, but if it means what I think it means, That sounds bad because it's in the middle of the program. How would you have a tail call? Maybe it means something else in LLVM. But the way I understand tail call is usually means it's the last call in your program, and therefore you can directly you can do tail call optimization, right? Am I right, guys? Where's the call instruction? No. Call instruction. Tail. It can be ignored. Okay, then it shouldn't be the problem. Yeah, this is where I would expect a tail call, right before a ret. Again, my knowledge of this is quite superficial, so it might be wrong, but having a tail call somewhere in the middle of the function makes no sense to me. Yeah, that's where you expect it. So this seems like why do we have, is there a ret somewhere around even? Nope. So I don't know how this, like, why the optimizer puts in a tail call somewhere in the middle of a function. Like, I'm pretty sure it's not there in the non-optimized version, but we can check. So we are looking for allocator proc something. Come on, there, allocator proc. This one is even bigger. That's more than 2 million lines. We're gonna make Vim's life easier again. Okay, we're looking for, where is this tail call? Jump if successor 1. 181 has a call, yeah. This is the call. Yeah, it's a regular call. The optimizer turned it into a tail call in the middle of the function. Don't know why. It seems like a bug. But maybe there's a reason for it. I don't know what the optimizer does. I don't know why it would introduce that hint. Maybe this is the call that breaks. We don't know because, like, luckily we get no information about, like, there's nothing here. At least they told us where it is, but that's about it. So we have to do the following, which is fun. We're gonna grab the whole LLVM code base for this error message. This is gonna take a while, especially on Windows where rip grab is way slower. Well, the title does not spell anything good from the interview of Hanselman with Latner. Oh, yeah. Exactly. He's now working on Mojo, but it's not his first language anymore. So since Chris Latner seems to be competent generally, like, I don't say he's stupid, that's why LLVM is bad. I'm saying this was his first thing, so that's why it's bad. So I don't think Mojo is his first thing, so can be good. I don't know. How feature complete do you estimate the compiler? Very feature complete. Not quite. Depending on your definition of feature complete, as in, like, we don't have an optimizer pass. Like, there's lots of features we want to get in. There's many things performance-wise we want to improve. I want to do a pass on the cross-compilation part because that was my first time ever designing cross-compilation into a compiler. And it was the first big thing I did in the compiler. So it was my first of something, so it's bad. Yeah. The other changes I did was moving away from using the global context. Basically migrating from LLVM blah to LLVM in context. And that, do you think that made it faster, or is it just something you did? Like, did you check if it was faster or slower, Ryuk? I like, this is something we actually, like, to LLVM's credit, this is something they mention in their where is it? Don't we have it open anymore? LLVM release notes. This is something they mentioned somewhere here. Yeah. Use LLVM context. I mean, it's a C API. We don't use the C API, but still, it's probably affecting us in some way. Have you tried using LLMs for debugging or documenting unknown code bases? No. No. I use LLVMs in limited contexts. I wouldn't, nope. I've used them to look up, like, there is this, someone mentioned it relatively recent. There is this page that basically auto generates LLM-based documentation for any GitHub project, and you can ask questions in there. I've used that a bit. Results were mixed. Okay. Where were we? So, yeah, weak rep for that, right? Okay, we found a bunch of stuff in the tests. We have one hit, perfect. So what we're gonna do is, I'm gonna translate blah. Okay, so what we're gonna do. Oh, look, it is probably related to the tail call thing. We're gonna open this file in Jai. We're gonna change back to compiling against the debug version. Luckily, I have already built this. With great foresight, I have built the debug info version. We're gonna open this one. Unable to translate. Let me show you how I tackle this. Is the last thing before I stop the stream, but I show you how I tackle these kinds of things. So luckily we have something with debug info, so we can rebuild. Doesn't really matter, I'm afraid. Yeah, let's build a release version so we can finish before the sun burns out. This is not up to date. You're lying. I just moved the debug version. You should. Oh god, did it not? Okay, let's do a clean rebuild. Nope, I said clean rebuild. And hope that it picks up on the fact that these directories exist now. And then while it does that, we're gonna change our debug target for release. We're gonna say, oh, perfect, it's already there. We just have to say final. And then I'm gonna hit that breakpoint, and then I show you one trick to make your LLVM debugging better. It's the only trick I know, but it's useful if you ever have to work on LLVM, because there's one thing you can do. Like, okay, I'm gonna show you the problem when you debug LLVM, and then I show you the only solution I know to make it not a nightmare. It is still a nightmare, but it's the only thing I know how to navigate at all. If I ever become a YouTuber, this is the one trick to improve your whatever. Come on. Oh, it's done. It didn't just stop scrolling. Of course, perfect. Okay, we're gonna run the build. Developers hate this trick, yeah. LLVM developers do not want you to know this one trick to make you a 10x programmer. Doop de doop. Doop 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 doop. Okay, there we are. We hit it. Okay, we have an instruction here. Good. If you want to see, oh, of course, I have an instruction. So it means I'm in a debugger. So I can probably, I mean, we're in an optimized build because you can't use unoptimized builds of LLVM for many reasons. So we have to see if we even have the instruction. Let's throw all of this away. Is inst something that survived the optimizer? Nope, that's bad. That makes things harder. Where do we get inst from? Fuck. It's from an iterator, so it's somewhere in basic block. We have basic block. We don't know where we are in this instruction list. Oh no, oh no, oh no, oh no. So we would have to rebuild this now with something that makes instruction not go away in the optimized build. Fun. I'm going to show you what I'm doing anyways. So assuming we had instruction, like it works for pretty much anything in LLVM. Like if you say, oh, I have okay, I'll show you the problem. We have a basic block here, okay, which is basically a chunk of code that you can only enter from the top. Like there's nothing that jumps into, and like it's a list. A basic block is a list of instructions that can only be entered from the top. Okay, so there's nothing that jumps into the middle of a basic block by definition, because that would split the block. So we have this basic block, and you would say, oh, it's a basic block, so I can look into it, right? Well, you want to see the instructions that are in there. It has an instruction list. We are in a debugger. Debuggers are great for looking at what your program does, right? So you go into the instruction list. Okay, where are the instructions? So I have an LLVM ilist alloc traits. I have, like, this is, you see, this is what I can see in the debugger. Okay. See, I think I might have found something. So if you unfold everything you can unfold, you might see this. This is LLVM ilist detail node based pref next. There's a pref and a next. So I assume if I go to no. But where's the, I have a parent. I have a number. There's an instruction. Like, where the, can you follow me? Like you have a basic block. It contains a list of instructions. You can iterate it. How can I see the list of instructions in the debugger? Want to know the answer? You can't. Awesome, right? Okay. So let's say I'm a poor third-party developer that wants to know something about this, whatever the heck is going on here. Here's the trick. Careful. Is it? But it is a value. Is it a? No, it is a pointer. It should work like that. Oh, now I'm sad. The dump function exists on pretty much any LLVM object, definitely on values. And it dumps the IR for this node, which is the only way I know to see what's in a node, like in pretty much anything. So that's very sad. We have a function here. Let's see if we can dump the function. It won't help us in this case, but function is not a pointer. Dump doesn't exist. Am I going nuts? I've used this. I'm sure this exists on value. Let me check. Maybe I'm misremembering something. Value.h LVMIR dump. This is the thing. Support for debugging, callable in GDB. Yeah, great. For some reason, it doesn't work for these. Even though, let's check. We have a basic block. .h. typo. Basic block.h. Basic block is a value. Basic blocks are data objects also. So it is a value. So it should be dumpable. For some reason, this seems like it did not survive, like the dump of basic block for some reason did not survive the optimizer, which is very bad. Shit. That's a shame because usually this works. Like this is the only thing I know of how to make sense of an LLVM code base. If you're like this, like you're breaking somewhere in a debugger and like, holy cow, what am I even looking at? This is usually what saves you, the dump function. For some reason, it vanished. I'm sure this, like I've used this on LLVM 21 on a release build with debug info 2 days ago or something. They should have added make procedure live in C++, yes. This is bad. So we can, of course, we can work around this. I'll show you. We were looking for, what was the error message? The problem is this will not happen on stream. Unable to translate instructions on call. So we're gonna say here, inst dump. Yeah, because we're thank you. I really needed this pop-up while I was typing. I'm so grateful that you did. Just die, please. So we're gonna do this, okay? And that means it's gonna survive. That means we're gonna break here. And it means we need to stop, and that means we need to recompile LLVM. Yay. I have this awesome script that I showed before that does it. The problem is this one reruns the configure command, and we don't want that for this particular case because it just takes forever. So I'm gonna, unfortunately we don't print it, but it should, okay, that should be doable. We're gonna go here. Where do we run this? In the build there. Okay, so we're gonna go cd win rel with debug info. We want the non-debug CRT, so x64 build. And here we're gonna say, hey, where was I? ms build m8 p configuration is, what's the build type? I think this is MT something. It's the second argument to LLVM variant. It's release type, which means, this is rel with debug info. Rel with deb info, okay. I don't have this, I should get this automated, but no, what? Hey, where's the thing I just typed? Where is it gone? Fork. ms build m8p con. I want a global mute button. Okay, p configuration equals rel with deb info install vcx project. Someone said that they know how to use cmake to create a ninja script that's way faster. Someone said that in chat earlier. If someone knows how to do that for Windows LLVM builds, please send me a message or DM or whatever, or mail, because I'd be grateful for anything that makes this go faster. By the way, in case you didn't notice, we changed one line in a CPP file, okay? We added this line in a CPP file. You see what's happening, roughly. It compiles for many, many seconds. And we have an error, which is a shame. The link one, okay. So it's inst.dump. Oh, if that is true, no, but we tried it with a dot, right? Let's do this again. Like, it just basically outputs that all of these are still up to date, but it takes, I don't know, 15 seconds for it to see that everything's still up to date. Doop doo doo doop doo doo doop doo doo. Bye tool. Yeah, again, I have to stop in a minute because I have to prepare some steaks. But of course, yeah, sure, this is slowed down by the slow shell, obviously. But I can't pipe the output into some file because the round trip's slower if there is a problem. Yeah, you can't win this one. I'm glad that you tell me about all the files that are up to date. This is so valuable. Any questions? Any comments? We changed one CPP file just for the, like, one. This many. I recently, like, I'm trying to get, like, I've been subscribed to the computer enhanced, like the programming aware, like the performance aware programming course by Casey. Literally on day one, I subscribed. Like, I got the mail where he announced it and I immediately subscribed. I still remember where, like, I was in Denver back then and was talking to a friend of Casey and like, oh, look what Casey's, like, released. I'm going to subscribe. I've been subscribed ever since. I watched the intro course, like the intro part of the course, but then life got busy and I stopped following. So I'm way behind and I've been, like, around somewhere before Better Software Conference 25. I did a, like, speed run through a bunch to catch up a bit. And then I stopped again. And now for the past 2 weeks or something, I've been doing another speed run and I'm now about 2 years behind. So I'm now somewhere in April or May of 24. And one of the episodes that I just watched, which is 2 years ago, is Casey. No, so I think it was Computer Enhanced. Maybe it was a Jeff and Casey show episode. No, I think it was a Computer Enhanced episode that I listened to yesterday or 2 days ago, where he was like, if he's going to stop using Clang, because he compiled his code base, whatever it was, he compiles it with Clang and Visual Studio, and so MSVC, not Visual Studio. And he was going to stop using Clang because it's 10 times as slow as MSVC. And with MSVC, he can build all his builds, like all targets, debug, release, different processor instruction sets, etc. Within a second. All builds together take a second. And he's like, if it's going to take more than a second to do all builds at the same time, he's not interested. And that's why he's going to drop Clang, because Clang got so slow that it now takes 10 seconds. I think this was in the Computer Enhanced course. Maybe it was a Jeff and Casey show. Maybe I'm not sure. And, like, compare this to this. Like, we change one file and we wait for, I don't know, a minute for the build to continue. Of course, this is a much larger code base than Casey's, obviously. But just, like, having these kinds of standards is useful. Oh yeah, I've heard stories about Epic internals. Like they cannot afford to use a slow compiler. Like they are hitting so many, like the Fortnite code base has. I shouldn't talk to. I don't know how much of that is public. No, I'm listening to the old. I'm on my third run through the old Jeff and Casey episodes, and I'm somewhere in 2010 now. Again, anyways, like yeah, Epic has problems with, like they're hitting limits in all kinds of ways. So okay, so we dumped, and it's the tail call. See, like without, but this is what you get when you call dump. And now that dump exists, we can call it here, hopefully. So, oh, we couldn't call inst dump because inst was optimized away. Yeah, it doesn't exist. Even now that we called it, it doesn't exist. But this is what the dump function does normally when you are able to call it. I assume bb dump doesn't exist. Has no member dump. And also it's a pointer actually, so it should be. Oh, now it works. Now it works. Look, guys. If I command, yeah. So this is what I use to debug LVM normally. So calling the dump function here made it appear. Luckily, that's good. So you can use this if you have to ever debug LVM. I hope you're never in that position. If you're in that position, consider what life choices brought you there. But since it's too late at that point and you are in that position, calling the dump function in the compiler, in the debugger, gives you the IR output of that thing. And here we can see the basic block with all its instructions. We used it to see the actual instruction we're working on because nothing in the debugger, like they managed to build LVM in a way that the debugger interface is completely useless. I'm not talking about the problem with that optimizer removes things. Even the things the optimizer did not remove are completely useless because you cannot inspect them in the debugger at all. At least I don't know anyway. You saw this before, like we stepped through this. There's nothing in here that gives you any information about that basic block except for dump. If you dump it, you see it here, and then you can go to your IR files that we have output, and you can find the thing and look at it. That's the only way I know how to debug what's happening in LVM. So now we have the problem that clearly the optimizer inserted a tail call in the midst of the function. Why? No idea. Debugging that is going to be a fun weekend project. It appeared when we enabled this global... where was it? Oh, this was in the compiler. It appeared when we tried to make LVM not dog slow by doing this global... Where is it? LVM converter. Yeah, this one, global ICEL, which is supposed to make things faster. It breaks things. Looks like it. Yeah, I don't know what to do about that. I'm gonna experiment a bit, but this looks like it's not gonna be fun. It's gonna be a lot of work. But if it makes our LVM release builds a bit faster, that would be awesome. So I'm gonna spend some more time on it, but I have to stop now to put some steaks in the oven. So them having to create their own linker because of that kind, yeah, like they're running into limits on the amount of things you can put into the PDB file, the debug info file. Their debug info files are gigabytes big, and they're hitting internal limits for a kind of things, so that's not good. Oh, and Afonso says it's been discussed up online. That's good. Okay. All right. See you all. Thanks for coming by. I hope it was interesting, despite us not doing very much on LVM. I mean, this was some LVM internals, but I hope it was interesting. I hope we see each other more frequently, but I can't promise anything. So thanks for coming by. Thanks for coming by. We should raid someone. We got raided twice. We have to pay it forward. you can, if you guys see a valid rate target, let me know. I'm gonna look around for a second. I haven't used the Twitch UI in ages. How do I even find the software engineering, the programming category nowadays? What's it called? Where? Oh no, I should know that. We'll figure it out. We'll figure it out. Where are we streaming? We are in. Where do I see? Where? I can't even see where I am streaming right now. Software and something, right? I love auto-playing stuff. Okay. Wow, we're number one. Ooh, Jackie is still there. Nice. I haven't I haven't looked for age. We could rate Jackie. She just does Godot stuff, so no low level stuff, but she was pleasant to raid a long time ago. Who else is there? Is this sorted by? Yes. Mulberry, Minecraft launcher, Pandora. What the heck does that even mean? I see a website. This is not serious programming. No, I'm kidding. Entwickler. I can't see Entwickler. Oh, of course, because it's paginated, but like that means he has one viewer or something? No. Making Wolfenstein, but a camera is your weapon. Godot. We have Uncle Scientist. He's been here for ages. Is everyone doing Godot nowadays? Assembly hacking cryptography. Shall we take this one for a ride? Let's see. This seems rateable. No, I wanted to copy. No, don't make everything a link. I want to copy this. Oh, fork. Okay. Well, guys. I wish you fun with Jesper, I guess. And we'll see each other soon, maybe someday, hopefully. Bye, guys.